Hello, we're on 5.01 geometry notes today. And we're talking about triangles. We're going to talk about classifying them. We'll talk about the sum of their angles and the exterior angle theorem as well. So a bunch of different things about triangles. So first of all, let's talk about how to classify a triangle. So to classify it, you can do that by its sides and its angles. So every triangle can be classified by its angles and its sides. So let's first talk about how to classify them by its sides. If you know that you have three congruent sides or three equal sides, then we would say that that is an equilateral triangle. And let's just draw a picture of that as well. So equilateral. Okay, well, now if we have just two congruent sides, that's called isosceles. And if you have three different length sides, that's called scalene. So you'd have all three sides would be different. Okay, so those are the three different possibilities. So if we're classifying it by its sides, so you either have no sides are the same, two sides are the same, or three sides are the same. Next, let's classify by angles. Okay, so first off, if we have a right triangle, that means we have one right angle, and then we'll draw a picture of that. And you can only have one right angle because if you had two, you'd already be at 180 degrees, and we know we have 180 degrees in the whole triangle, which has three angles in it. If you have an acute triangle, that means you have three acute angles. And remember, an acute angle means it has to be less than 90 degrees. So that would be an acute triangle. If you have an obtuse triangle, that means you would have one obtuse angle, which means you have one angle that's greater than 90 degrees. And the last option is if we have an equiangular triangle, which just means that all three angles are congruent or equal. And that would also end up being your isosceles triangle. Or sorry, your equilateral triangle would also be your equiangular triangle. So it'll have three congruent sides and three congruent angles. All right, number one. So if segment AB is congruent to segment BC, solve for x, and then classify the triangle. Okay, so first, give you the drawing. So this is A, B, and C. This side is 2x minus 1. Over here is 9, and this is x plus 4. All right, so we know segment AB is congruent to segment BC, so we mark our picture. So that means those two are the same. So now solve for x and then classify. So in order to classify, you need to substitute in. So we'll do this one together. So 2x minus 1 equals x plus 4. Since we know those two are equal, subtract over your x, add over your 1. You should get x equals 5. Then it says to classify it. So in order to classify it, I need to sub back in so I know the lengths of my sides. So 5 plus 4 is 9. 5 times 2 is 10 minus 1 is 9. So while I may have thought it was isosceles by the given, it's actually equilateral because all three sides have length 9. So if it's equilateral, that also means it must, so that's by its sides, how we would classify it. From the sides table up here, you choose one of these. And then from the angles, we know if it has 3 congruent sides, it has 3 congruent angles. So it's also equiangular. All right, number 2. The ratio of 3 angles in a triangle is 1 to 3 to 5. Find the measure of each angle in the triangle, and then classify by sides and angles. Okay, so anytime you see this a ratio problem like this, I recommend putting an X next to each of your numbers. So I know those are my 3 angles. So I know that 3 angles in a triangle add to 180 degrees. So I'm going to take the smallest angle, 1x, plus 3x, plus 5x, my 3 angles, and set them equal to 180 degrees. And now solve. So pause the video here, solve for x. All right, so you should have gotten x equals 20. Then we want to classify it. So in order to classify by sides and angles, we need to know what those sides and angles are. So let's substitute the 20 back in for each of our angles. So one of our angles is 20 times 1, so 20 degrees. And then 20 times 3 would give us 60 degrees. And 20 times 5 will be 100 degrees. So looking at these angles, 100 is bigger than 90. So that tells me I have an obtuse triangle. If all 3 angles are different, that also tells me that all 3 sides are going to be different. So to classify it by its sides, it would be scalene. And by its angles, it would be obtuse. So a scalene or obtuse scalene triangle or a scalene obtuse triangle. So by its sides is scalene. And by its angles, it's obtuse because it has one obtuse angle. And again, use those charts to help you figure that out. Okay, let's do one more. Find the measure of each angle and then classify the triangle by its sides and angles. And I'm going to give you a picture for this one. So this one over here is x minus 2. Here is 2x plus 50, and these represent the angles, and this one is x. So pause the video here, find x, then find the measure of each angle, and classify the triangle. All right, so hopefully you took all of your angles, so x, x minus 2, and 2x plus 50, and you want to set those equal to 180 degrees. Solve for x. Then you should have gotten x equals 33. And you guys should have all the work showing how you got x equals 33 on your notes. Now I need to substitute that in. So you should have gotten 33 31, and this would be 116. So based off of that, I have 3 different angle measurements. So I know I'm going to have a scalene triangle. So 3 different angles means 3 different side lengths. And I have one obtuse angle, 116. So this one, again, would be an obtuse scalene triangle, or scalene obtuse, doesn't matter for that one. Okay. Next up, we're going to talk about the exterior angle theorem. So in a triangle, the measure of an exterior angle is equal to the sum of the remote interior angles. What does that mean? So here's a triangle. If I want to find an exterior angle, I'm just going to extend one side. So keep going in one direction. You could have an exterior angle at either side. But if you're looking at your exterior angles, you always have to go in the same direction. So if I want to extend more than that one, I would go off here and then here. So if we're looking at this exterior angle right here, let's call that 3. That's going to equal the sum of your remote interior angles. So to decide where your remote interior angles are, it's going to be the 2 angles that are not touching that exterior angle. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3. So the remote interior angles are the angles not touching that exterior angle that you're looking at. So if I want to, let's call that 5 and 6. So if I was looking at the exterior angle at 5, that would equal the measure of angle 1 plus the measure of angle 4 would be your remote interior angles. So the 2 interior angles not touching 5. If I was looking at the measure of angle 6 as my exterior angle, that would equal, hopefully you can fill this in, measure of angle 2 plus the measure of angle 4. And that's very helpful sometimes when we have variables and we can't find the angles. So number 4, find x and y. And extend over here. Here's x, here's y, here's 80 degrees and 25 degrees. We'll call these, give them some letters here. Okay, so if we want to find x and y, you've got a couple different ways you can do it. You could find y first in this one, so add 80 and 25 together to get 105, and then subtract that from 180 degrees. Or you can use our new theorem that says the exterior angle is equal to the sum of the remote interior angles. So 80 plus 25 will give us our x. So that's 105. And then just subtract that 105, since these form a linear pair, or add to 180, just subtract 105 from 180. Or you could have thought about it as the triangle and subtracting 80 and 25 from 180 to find the third angle of the triangle. So that will give us our y. So y is 75. Let's look at another one. So let's say this angle out here is 2x plus 15. This one's x, and this one's 67. So this one we can't find this third angle very easily because we already have a variable inside of our triangle. So instead of doing like 180 minus 2x plus 15 and then adding these 3 angles together, which could get really confusing, we use our new theorem. We say the exterior angle is equal to the sum of the remote interior angles. So pause the video and see if you could set that equation up. So you should have x plus 67 equals 2x plus 15. And then you would solve for x, so subtract over your x, subtract over your 15, and we get 52 equals x. Number 6, find the measure of an exterior angle at the base of an isosceles triangle whose vertex angle is 40 degrees. Okay, so we don't have a picture in this one, so we really have to focus on what is being asked and maybe draw our own picture. So we know it's an isosceles triangle, which means it has two congruent sides. We know the vertex angle is 40, so that's not the base angles. And we want to know the measure of the exterior angle at the base. So we need to extend one of the sides. It doesn't matter which one. I'm going to extend that one. So I'm looking for this angle over here. So how could I find it? There's a couple different ways of doing this. Pause the video and see which way you can figure out. All right, so what we would do here is I would take 180 degrees, because I know that's in the triangle, and subtract my 40. So now I have 140 degrees left for these two base angles. So now I'm going to take 140 and divide that by 2, because I know that these two angles of my isosceles triangles must be the same. So that gives me 70 degrees. So now you have two different options from here. You could either look at these two and say they form a linear pair, so they form a straight line, they must add to 180, do 180 minus 70, or you could say these two angles have to add to my exterior angle, so 40 plus 70 would give me 110. So either 180 minus 70 gives me my 110, or 40 plus 70 gives me my 110. Either way, final answer is 110. Number 7, find x. This one I'm going to give you a picture for. So this angle out here is 59 degrees. In here is going to be 29 plus 2 rad 3x. I know you guys need a little practice with those radicals. And this angle right here is going to be 12 plus the square root of 3x degrees. So here, again, we don't know this third angle. We have variables already in our other angles. So you could subtract from 180 for 59 to do this one, but let's use our new theorem where the sum of the remote interior angles equals your exterior angle. So we're going to take 29 plus, it's doing some funky things here, 29 plus 2 times the square root of 3x plus 12 plus the square root of 3x, that's a 3, not a 1, equals 59. Pause the video, see if you can solve that on your own. All right, 29 and 12 I can add together here, and that's going to give me 41. These two I can add, they both have a rad 3x. Here's 2 rad 3x plus 1 rad 3x would give me 3 rad 3x. So you keep whatever's underneath the radical when you're adding or subtracting. Now we're going to isolate that radical. So I'm going to subtract 41 from both sides first. You get 3 times the square root of 3x equals 18. Isolate my radical, so I need to divide by 3 on both sides. So I get the square root of 3x equals 6. Now to get rid of my radical, I can square both sides to get 3x equals 36, and then divide by 3, and x equals 12. All right, let's do number 8. So this one, I want you to find x, y, and the measure of angle SEL if the measure of angle FEL equals x plus 30. The measure of angle SEL, which is one of the angles we're looking for the measure of, equals 8y plus 75. I don't know what's going on with this today. The measure of angle EFL equals 12x plus 3. And the measure of angle ELF, or ELF, equals 8x minus 21. So here is your picture. And that's a straight line right there. Okay, so that's S, F, L, and E. Again, this one right here, SEF is a straight line. It's hard to tell in my drawing, so I'm just going to write that out. Okay, so pause the video here and label all the angles that you know and see what you can do with them. So I've got FEL right here is x plus 30. I know that angle SEL over here is 8y plus 75. I know EFL is 12x plus 3. And the measure of ELF is 8x minus 21. Okay, so we have an exterior angle over here, 8y plus 75. So we know that'll equal the remote interior angles. So pause the video and see what you can do from there. So if I set up that equation, I'd have an x and a y there. So maybe we can find x first. So notice in my triangle, I have 3 angles. They're all in terms of x. So I'm going to add those all together to see if I can find x first and set those equal to 180. Okay, hit pause and solve for x. All right, so you should get x equals 8. So you would have gotten 21x plus 12. And then 21x equals 168. And then x equals 8. Okay, but we want to find x, we want to find y, and we want to find the measure of angle SEL. So now I'm going to find y. And for that, I could use that these 2 angles right here add to 180 degrees. Or I could use the sum of the remote interior angles equals 180. But for either of those, we're going to need to sub in to find x. So I'm going to sub in here. So this is 38 degrees. This one's 99 degrees. And this one, 8 times 8, 64 minus 21 would be 43 degrees. Okay, so choose whichever way you're more comfortable with, or maybe choose the way you're not comfortable with, and find the measure, find y. All right, so since most of you are probably least comfortable with the sum of the remote interior angles, I'll do that way. So that way you would take 99 plus 43 and set that equal to 8y plus 75. And then you would solve for y. And we would get 142 equals 8y plus 75. Subtract your 75, divide by 8. And I'll let you guys do that on your own. And then that should be 8.375. Okay, and then lastly, we want to find the measure of angle SEL. So we're just going to substitute in to find that. So we want the actual measurement. So 8 times 8.375 plus 75 And you can type that right into your calculator, and it should give you 142 degrees. All right. And next one that we're going to talk about is two little theorems that you need to know. So in a triangle, the larger angle lies opposite the larger side, or the longer side, let's say. Also, in a triangle, if you know the longest side, then you know which angle is the longest. The longer side lies opposite the larger angle. So think about, usually in class I use a pipe cleaner and I show the pipe cleaner really small. And I say, okay, well look at the side across from it over here. That's across from that. And what happens if I make the angle with that pipe cleaner even bigger? What happens if you were to connect the ends of that pipe cleaner? Well, as the angle gets bigger, the side across from it gets bigger. If the angle's smaller, the side across from it gets smaller. And that's all that is really saying right there. So I want you to list the sides of this triangle from longest to shortest. And be really careful, because sometimes they'll ask you from shortest to longest, sometimes longest to shortest, but really be aware of what is being asked of you. Okay, so I'm going to give you angle A is 80 degrees, B is 30, and I'm not going to give you C, but I want you to find the sides from longest to shortest. Pause the video and try to do that. All right, so hopefully you realized you needed to find angle C first, so you would take 180 degrees and subtract your 30 and subtract your 80 from that, and that gives you 70 degrees. So I know this is 70. Now, my largest angle is 80, so across from that is side BC, must be the longest side. My next largest is 70 degrees, so across from that is side AB. And then my smallest angle is 30 degrees, which is angle B, and that's across from side AC. So that would be all you need to do to list them. All right, and our last problem that we're going to do is I'm going to give you some coordinates, and you're going to want to graph these, so it'd be good if you have graph paper here. So if not, pause the video, go grab some. Given the coordinates of the triangle, A is -2, 1. B is 1, 5. Oh, that's really, I don't know why this is writing so connected. And C is 2, 3. Maybe I'm writing different today. Okay, so first I want you to graph that triangle. And then I'm going to want you to find the length of each side. And you can do that using your distance formula to do it algebraically of each side. Okay, so draw our grid, our X and Y axes. Go ahead and plot these. So -2, 1, label it A. And 1, 1, 2, 3, 4, 5 is B. And 2, 3, 1, 2, 3 is C. Connect those. Okay, so we want to find the length of each one, so don't forget your distance formula. So you've got x sub 2 minus x sub 1, and you should be pausing here, and you should have written this down on your own. And there's our distance. So now I want you to use that distance formula to find the length of AB, find the length of BC. To see, again, I'm sorry, I don't know what I'm doing differently. Something worse, AB, BC, and AC. So pause the video, go ahead, use your distance formula to find the length of each of those. All right, so I'll show you, I'll do AB with you just to make sure everybody's on the same page here. So I'm looking at coordinates for A and B. We can call this x1, y1, x sub 2, y sub 2, and then substitute in. So you've got 1 minus negative 2, so that'll become plus y sub 2 is 5 minus 1, quantity squared. So that would be the square root of 3 squared plus 4 squared. So that's 9 plus 16. Remember, you cannot separate a radical over addition, so we have to add those to get the square root of 25, which is 5. So AB equals 5. Okay, pause the video and find the other two. All right, so for BC, you should have gotten the square root of 5. And for AC, you should have gotten rad 20, which we can simplify into the square root of 4 times the square root of 5, which would be 2 rad 5. And then what would be helpful is to find the decimals for each of those. So type those right into your calculator and find those decimals so that we can answer the next question. All right, so those decimals would be, so you're just typing in 2 times radical 5 in your calculator would be about 4.472. Rad 5 in your calculator would be about 2.236. The reason I want to get those decimals is because now I want you to list, we're on part C, list the angles from largest to smallest. So in order to do that, we need to know which side's the largest side. So we've got about 4.472, 2.2, and then 5 for the third side. So the biggest number out of those is 5. So that's the longest side. This one is the shortest side because it's the smallest number. So if the longest side is AB, which angle is across from AB? So the angle is going to be whatever point is not one of those two endpoints. So angle C would be our largest angle, and A would be our shortest. Our smallest angle would be angle A, I mean. So angle C is your largest, then angle B, and then your shortest side is BC, which means the angle across from that would be the smallest angle. And then I want you to classify the triangle by its sides. Pause the video and write down what that classification would be. And hopefully you realize that all 3 sides are different, so this would be a scalene triangle for that one. All right, and that will be it for our notes today. If you have any questions, please let me know. And we'll talk more about how you could also classify this by its angles as well. We'll be talking about that more later on. All right, again, if you have any questions, please let me know. And I hope you guys have a great day. Pie out.